Welcome to the Math Record. Today I'll be covering the ICTM State 2017 Division AA Geometry, which I'll be answering questions 11, 13 in this video, and then questions 14 and 19 in the next video. As usual, scroll down to all 20 questions, and I'll provide the answers at the end. Okay, now let's go to number 11. Line L with the equation 3x minus 4y minus 4 is equal to 0. Intercircle O with equation x minus 1 squared plus y plus k squared equals 25 and exactly 1 point P. Determine the sum of all possible values of k. Okay, so basically this question is kind of common. Basically what you do is that you substitute one variable with another and you transform it to a polynomial, and then you only find basically the one solution for that polynomial. So we could just rewrite this as 3x is equal to 4y plus 4 for a linear. So I just move 4y and 4 to the other side, and then we could just divide by 3. So x is equal to 4y plus 4 divided by 3. So we have this equation. And now we're going to substitute it into our quadratic. So 4y plus 4 over 3 minus the 1, so minus 3 over 3, that's just 4y plus 1 over 3 squared plus y plus k squared equals 25. Okay, so I'm going to move this up because we're going to have to do a bunch of math. So this is going to be 16y squared plus 8y plus 1, and then 3 squared is 9, so this is 16 over 9, 8 over 9, and 1 over 9. This is going to be y squared. This is 2ky, and this is plus k squared. And then this one minus 25, so we set this equal to 0. And then we're going to combine our like terms, so 16 over 9 plus this y squared, which would be 25 over 9y squared. The linear terms, which is 2k plus 8 over 9y. And then our constant terms, which is k squared, negative 25, and 1 over 9. So now we have a polynomial. So for it to intersect at only exactly 1 point, that means it only has one solution for y. So if there's only one solution for y, that means using the quadratic formula, which is negative b plus or minus b squared minus 4ac over 2a, that means this b squared minus 4ac has to be equal to 0, because adding 0 and minusing 0 is basically the same thing, so there's only one solution. So b squared minus 4ac had to equal 0. So that means 2k plus 8 over 9 squared minus 4, your a, which is 25 over 9, times your c is k squared minus 25 plus 1 over 9 is equal to 0. Okay, so we have this. And all we have to do is simplify it now. So this is 4k squared. That's 16. That's 32 over 9k. And then this is 64 over 81. So this is negative 100 over 9. So minus 100 over 9k squared. And then 100 times 25 is minus 2,000. Well, negative and negative makes a positive. So positive 2,500 over 9. And then negative 100 over 9 times 1 over 9 is negative 100 over 81. Okay, so this is equal to 0. So combining like terms again, 4k squared minus 100k squared. This is the same thing as 36 over 9. So 36 minus 100 is negative 64 over 9k squared, plus your linear term, which is only the 32 over 9k. And then you have your constant term here, constant term here. And whatever these add up to your constant, it doesn't really matter, because the only thing that matters is that we're looking for the sum of k. And another thing that's unique about polynomials is that the sum of all values for k is always whatever this constant is divided by this constant. And this constant should be negative. So, well, negative for this, since this is positive, that means this is actually negative 32 over 9. So if this was like negative 1, the thing is actually just 1. But since this is positive, this is negative 32 over 9. And then this value divided by your leading coefficient, which is negative 64 over 9. And it's just a really cool property for polynomials. So 32 divided by 64 is 1/2, because 9 over 9 just cancel each other out. And that's your answer for number 11. So that's all you have to do. Okay, now question 13. In triangle ABC, AB is 6 and BC is 9. So let's kind of draw that out. So A, B, C. AB is 6 and BC is 9. D lies on AC such that ABD and DBC are similar, so it's an angle bisector. So this angle is equal to this angle, and this point is D. And E is the midpoint of BD. So this is the midpoint where this line is equal to this line, so that's E. E. Okay. The area of ABC, so the entire triangle is 25. Determine the area of ABE. So we're trying to find this area. So we're going to use something called the angle bisector theorem, which basically means this side length divided by this side length is the same ratio as this side length to this side length because this angle is bisected. So that basically, so 6x, 9x, so 6x to 9x. So that's going to be a ratio. We don't know what the side length is. That's why I put x in here as a scalar. So that means the ratio of this area to this area is 6 to 9. So that means the ratio of this area to the entire thing is 6 to 6 plus 9, which is 15. So that will be 6 to 15. So that gives us this area out of the total area. And then out of this area, we cut it right here, and you kind of turn your head sideways. This area to this area is equal to each other because this is a midpoint, and these sides are equal. So that means we just need to take half of it to just get this area. So this is basically just scaling from the big triangle to this side, to this triangle. So what is our big triangle? That's 25. So we could just do some math. So that's 5. That makes 3. Cancel with this 5 to make 5. This 3 and the 2 will cancel with the 6. So our only answer for number 13 is 5. Okay. And as promised, here are all answers for all 20 questions. Well, thanks for watching, and I'll see you at the next math record.